So 15.3, we get to solve quadratic equations by completing a square and using a formula. So completing the square basically means we want a perfect square trinomial. So remember, if I give you like x squared plus 12x plus 36, this is a perfect square trinomial because notice how the first term is a perfect square. The last term is a perfect square. Remember, if you double these together, so if you multiply 6 times x and double it, 2 times 6x has to give you this 12x. So this means this is going to factor into x plus 6 squared, which we call a perfect square. So if we have a perfect square trinomial, we can turn it into a binomial raised to a power 2, a perfect square. Or if I had to say x squared minus, say, 10x plus 25. Notice how if we have this is a perfect square and this is a perfect square, if you multiply these two together, we have 2 times 5x, we have to double it. If that gives me my 10x, then this is going to be a perfect square trinomial. So this now factors into, because we need a negative there, this has got to be negative. So this has got to be then x minus 5 squared. So the middle sign will dictate whether the last term is positive or negative. If the middle sign is positive, we're going to have a positive, but if the middle sign is negative, it's going to be a negative. So if we look at x squared minus 5x minus 2 is equal to 0, notice how this is not a perfect square. So to solve this, what we can do is we can do a couple things here. So let's see here, x squared minus 5x minus 2 is equal to 0. The first thing we do by completing the square is we want to make the left side look like an incomplete quadratic. So what we want to do is we actually want to move the 2 back to their side of the equation. So this is going to leave us this x squared minus this 5x is equal to then this 2 over here. So what we want to do is we want to complete the square. To complete the square, what we got to figure out is what we can add here to make this a perfect square. Notice how what happens here is this has to come from the middle term. So notice that if I gave you, say, this x squared plus this 12x, how do I get this? How do I get this 36? So notice what we did is we actually take half of the 12, which is 6, and we square it, and that gives me my 36. So to complete the square, we take half of the linear term. In other words, we divide the 12 by 2. Once you divide 12 by 2, then we square it. I didn't do that very well, did I? So you have to divide the linear term by 2, divide the 12 by 2, and then square it. So if I apply this problem over here, what we got to do is take half of this negative 5, and I'm going to do this over here. So negative 5 divided by 2. Well, notice that negative 5 divided by 2 doesn't divide it evenly. So what we want to do is we want to now square that, and that becomes then this 25 fourths. So the way that I like to do this, I like to go ahead and just leave the negative 5 halves squared over here. But I want to go ahead and remember what you add to one side of the equation, you have to add it to the other side of the equation as well to keep it balanced. So I have to add the 25 fourths to the other side of the equation to keep the equation actually balanced. So what happens is this left side now factors into a perfect square because we made it. So this is going to be x minus this 5 halves squared. And then we just got to add 2 plus 25 fourths. So 2 plus 25 fourths, notice that that's a 2 over 1. So notice that my common denominator would have to be a 4. So you got to multiply this by 4, multiply this by 4. That's going to be 8 over 4 plus 25 fourths. So what we have then is we have this x minus this 5 halves squared is equal to then this 33 fourths. So we have this problem looks like this. So what we want to do is we want to do like we did a pure quadratic. We want to use the square root property here. So what I want to do is I want to take the square root of both sides to give it that power of 2. But when I do that, this has got to turn into a plus or minus over here. So this becomes then this x minus 5 halves. And then we have this plus or minus the square root of 33 over the square root of 4. So this turns into x minus 5 halves equals plus or minus the square root of 33 over 2. So to solve for x, we actually got to add the 5/2 to both sides. So I'm going to rewrite this problem. X minus this 5/2 equals plus or minus the square root of 33 over 2. I'm going to add this 5/2 to both sides to get x by itself. So what we have is what's called a irrational number. We can't actually add those together. So this becomes then x equals 5/2 plus or minus the square root of 33 over 2. And we really can't do anything with that unless we want to change it to a decimal. So at this point, I'm not going to go that far. I'm going to just leave that as that. So that's completing the square. Let me see if I can do another example here. I'm going to pause this for a second. So look at this 3x squared minus 3x minus 7 is equal to 0. You know, if we want to try to solve this by factoring, you know, we have this quadratic term here and this -7 here. And then we'd have to have 3 times -7 would be -21. And so what we're trying to do is find the factors of -21 to add up to -3. Well, the factors of -21 would be like a 1 and a 21 and a 3 and a 7. So 3 and 7 looks like a good choice. And it looks like the 7 would have to be negative. So 3 times -7 does give me this -21. But 3 plus -7 does not give me this -4. So what happens is factoring does not work. This is what's called a prime factorization. There's not any what we call rational numbers to factor this. So this is a signal to me that the answer is probably going to have what we call radicals in them. So we have to use a different strategy because factoring does not work. And this is why they introduced this completing the square. So to complete the square on this example, notice how there's a quadratic term with a coefficient of 3. What I want to do is get rid of that coefficient of 3 by dividing everything by 3. So we want to divide this side by 3, but we also have to decide this side by 3. So we have to divide each individual term by 3. So 3 divided by 3 gives me this 1, or x squared. -3 divided by 3 would give me a -1, or just -1x, if you will. And -7 divided by 3, just leave that as a fraction. And 0 divided by 3 would still just be 0. So we have that as our equation. So to complete the square, we just want the quadratic term and the linear term on one side. We do not want the constant on this side. So the constant's got to move to the other side of the equation. So this becomes then this x squared minus this 1x is equal to this 7/3. So now we want to complete the square. To complete the square, we take half of the linear term. So that -1, we got to divide by 2. But then we got to square that, which is going to give me this 1/4. So notice I'm going to just leave that there. So what this tells me then is what I'm going to do is I'm going to add a -1/2 squared here. And I'm going to add the 1/4 over here because I actually got to do that math. On the left side, we're just going to use factoring. So this is going to now factor into x minus 1/2 squared. Let me make that a little bit smaller here. So this becomes a perfect square. So it's going to be x minus 1/2 squared. And then we have to add 7/3 plus 1/4. I'm going to pause for a sec there. I'm going to get my calculator out because we're probably going to need it anyway. So back to our problem, we want to add 7/3 plus 1/4. Again, I could get a common denominator, but I'm just going to calculator do it. So alpha F1 is our fraction button. So we have the 7/3. And then we're going to add to that the 1/4. Hit enter. That gives us then this 31/12. So here we have this 31/12. Okay. So what we want to do from here is to solve for x, we want to take the square root of both sides. So we take the square of this. Let me use a different color there. So we'll take the square root of this side as long as we take the square root of the other side. Remember, this is where this plus or minus comes in. So this becomes in this x minus this 1/2. And then we have the square root of 31 over 12. So remember, the square root of 31's prime, but 12 would be the same thing as the square root of notice how we'd have 2 times 2 times 3. So notice that the prime factorization 12 will be 2 2's and 3. But remember, if there's 2 2's, I can bring a 2 out. So this becomes the square root of 31 over 2 times the square root of 3. Now remember, we're not allowed to have a 3 in the denominator, so we want to multiply the top and bottom by the square root of 3. So this becomes then the square root of 63 over then 2 times 3, which is 6. So what happens is this becomes then plus or minus the square root of 63 over 6. And then we can add the 1/2 to both sides, and we get x equals 1/2 plus or minus the square root of 63 over 6. And that would be considered our answer to that problem in exact form. Otherwise, we would have to change it to decimal. Now, one other thing you could do is, if you want to make it a single fraction, you could get a common denominator as well. You could change the 1/2 to 3/6. So you could also say x equals 6/2 plus or minus the square root of 63. I'm sorry, this should be a 93. Where'd I get that at? 31 times 3. That should be a 93. Don't, because 31 times 3 should be a 93. Y'all caught me, didn't you? So this 93 would be there. So we'd have square 93 over 6. I'm sorry. This should be 2/6. It's the same, or 3/6 is the same thing as 1/2. I need to slow down a little bit on it. So you multiply top and bottom by 3, that would be 3/6. So you could say this is x equal 3 plus or minus the square root of 93 over 6 as well. So either one of those would be acceptable. So in your homework, you may be looking for something like this, or something like that would be acceptable. Okay, that's what's called completing the square. So there's a little bit of work to be done there. So the thing is solving an equation using what's called the quadratic formula. So the quadratic formula, it actually comes from solving the equation by completing the square. I won't get into that here. So if I want to solve for x, if our equation is in the form of ax squared plus bx plus c, I can apply this formula. Remember how we were trying to identify what a, b, and c are? That's where this comes into play, is with the quadratic formula. So if I have x squared plus 5x equals 6, x squared plus 5x equals 0. Notice that, my first strategy would be factoring x squared and 6. Are there factors of 6 that add up to 5? Well, 3 and 2 would. So this would actually factor into, we'd have like 3x here and 2x there. So that would actually be, I'd factor out x there, x and 3, 2. Yeah. So notice how I would factor into x plus 2 times x plus 3 is equal to 0. X would equal then, x plus 2 would equal 0. And x plus 3 would equal 0. So you'd have x equals -2 and x equals -3 as my solutions. So that's using factoring. So that problem actually could be done rather easily with factoring. But they say use the quadratic formula. So let's see if the quadratic formula also gives me this -2, and this -3 as my solutions. So -2 and -3 were my solutions. Let me write that down. -2, -3, -2, -3. So we do that by factoring. So if I'm using the quadratic formula, we have x is equal to the opposite of b plus or minus the square root of b squared minus this 4ac all over 2a. So to use this formula, we have to identify the a, the b, and the c. Remember, the a is the coefficient of the x squared, which is the 1. The b is the coefficient of the linear term, which is the 5. And the c is the constant, which is the 6. So using the formula, we have x equals, then we got to take the opposite of 5. So it's going to be a -5 plus or minus the square root of. And then we have 5 squared minus 4 times a, which is 1, times c, which is 6. This is going to be over 2 times a, which is 2 times 1. Okay. So what I'm going to do is just use the calculator and just let it do all the work for me. So alpha f1, 1, that's what formulas are there for, is to use the calculator. So I have -5. Now the catch is I can't do plus and minus at one time. I have to choose one operation at a time. So I'm going to put a plus and then the square root symbol. And then we have a 5 squared minus 4 times 1 times 6. And then on the bottom, we would have 2 times 1. Hit enter. Notice how that gave me -2. Now, if I go up here and highlight this, like so, and hit enter, that'll bring it back down. If I go back through there and go over and change my plus sign to minus sign, so if I just highlight, get right over top of it, hit the minus sign, it should just type right over it. Hit enter again, and that'll give me the -3. So the quadratic formula would also give me those two solutions, x equals -2 and -3, by using the calculator. So if we look at this next example, use the quadratic formula to solve the equation in example 1b. So we have this 3x squared minus 3x minus 7 is equal to 0, round the answer to the nearest 100. So that's the one we did up here, I believe, part B. Notice how we got into a big old mess with that one. So let's see what happens with the calculator. So notice how it's already in standard form. So A equals 3, B equals -3, and C is equal to -7. So using the quadratic formula, we got to take the opposite of B. That's going to be a +3, plus or minus the square root of. Now the catch is, when you raise a -3 to a power 2, you have to put the -3 in parentheses. So -3 squared. Otherwise, your calculator will do that incorrectly. -4 times A, which is the 3. The C is the -7. And this is going to be over 2 times 3 on the bottom. So using our calculator, we can clear this all off. Alpha F1 and over D. So I have a 3. Again, I can't do them both at the same time. Plus then the square root of then in parentheses -3 squared minus 4 times 3 times -7. And then 2 times 3 on the bottom. This gives us then 2.10. Now sit around to the nearest hundredths place. So that's going to be where this 0 is. So I have to look at the third place, which is 7, which means I have to round the 0 up to a 1. So it's going to be 2.1. So x is going to be about 2.11 if I round it. So if I go up there and highlight this, use my directional pad, highlight that, hit enter, it brings it down. So now I want to just use my directional pad, get inside there, work your way over to where the plus sign is, and change it to a minus sign, hit enter. That gives me then this x equals -1.101. So 2.11 and -1.11. So the question is, did I actually do that math correctly? I kind of stumbled on all that math here. Let's see if we came close to that. So if I type in this 3 plus square root of 93 over 6, I'll try that one. Alpha F1 in over D. So if I have 3 plus the square root of 93 over 6, hit enter. Notice that does give me the 2.1017. So we did do that right. Then if I go up here and highlight this, hit enter again, if I change that plus to a minus, hit enter, notice that does give me this negative 1.101 So that would be, the math would check out. That's the same math. Okay. So complete the square, as you can kind of see, is an interesting way to solve some complicated problems, but the quadratic formula becomes quite easy, especially if I just want decimal answers.